This is Asfar Asad and you are watching the Saaz Academy's YouTube channel. Chapter number 2, the particulate nature of matter, subchapter number 2.5, covalent bonding. Covalent bonding is the sharing a pair of electrons to gain electronic configuration of an inert gas, usually for molecules. Covalent bonds occur between non-metallic atoms only. In covalent bond, we try to substitute electrons of two or more atoms between each other to form the 2 or 8 valence electrons. The shared electrons appear in pairs. Example, H2 hydrogen molecule. Hydrogen atom has one valency. To become stable with hydrogen atom, it needs one more electron, just like helium, which has two valency. When two hydrogen atoms join, they share their electrons, on which the share becomes 2 electrons, which is now a noble gas configuration being shared between these two atoms. We write the bond as HH single bond, which means they can share an electron pair of 2 electrons. Example number 2, CL2 Chlorine molecule. Chlorine atom has 7 valency and needs 1 electron each to form a noble gas configuration between 2 chlorine atoms. Hence, they share an electron each to hence share 2 electrons between the atoms. Hence, each chlorine atom now has 8 valency, which is a noble gas configuration. Example number 3, O2 oxygen molecule. An oxygen atom has 6 valency and needs 2 electrons each to form a noble gas configuration. Hence, each share the amount of electrons each short of in case 2 electrons to form a stable molecule. The contribution hence now become 4 electrons and what left on each oxygen atom is 4 electrons. We combine each 4 electrons on oxygen atom with the 4 electrons shared and hence we get 8 valency for each oxygen atom, a noble gas configuration. Example number 4, H2O water molecule. Apart from oxygen sharing between oxygen atoms, it can have electrons with other atoms. Oxygen needs 2 electrons and when bonded with hydrogen, which need an atom each, they combine to provide 2 electrons on both sides of oxygen bonded with hydrogen atoms. Each hydrogen with oxygen atom form a single bond, OH. Example number 5, CO2 carbon dioxide molecule. Carbon needs 4, oxygen needs 2. We share 2 from oxygen part, which has the smallest number of short electrons, to share the amount of electrons that atom needs to form 4 shared atoms. Now oxygen is stable but carbon needs 2 more, which we now know they can get from another oxygen atom. The atoms are now stable and since each bond has 2 pairs of electrons, we call this double bond, carbon double bond oxygen. A pair of shared electrons between 2 atoms forms a single bond, for example X single bond Y. 2 pairs of shared electrons between 2 atoms forms double bond, for example X double bond Y. 3 pairs of shared electrons between 2 atoms forms triple bond, for example X triple bond Y. Structure and properties of covalent bonds. Structure: giant covalent bond. Number 1, diamond. Diamond has carbon atoms bonded with another carbon atoms in a tetrahedral arrangement, which each carbon atom uses all its valence electrons to form 4 single covalent bonds with other 4 carbon atoms. Number 2, silicon dioxide. Silicon dioxide SiO2 has silicon atoms bonded with another oxygen atoms in a tetrahedral arrangement, which each silicon atom uses all its valence electrons to form 4 single covalent bonds with other 4 oxygen atoms. Number 3, graphite. Graphite has flat layers of carbon atoms bonded strongly in hexagonal arrangement, in which the layers are bonded to each other weakly. Properties. Number 1, it is a hard solid because it consists of many strong covalent bonds between atoms. This property makes it suitable as abrasives, a substance used for grinding, polishing, or cleaning a hard surface. Number 2, it has very high melting and boiling points. Number 3, it does not conduct electricity except graphite because there are no free electrons in covalent bonds since they are used to form bonds. Hence, electrons are in fixed positions. To conduct electricity, there must be free electrons. Number 4, all covalent structures are insoluble in water. Subchapter number 2.6, Metallic Bonding. Metallic bonding is bonding within atoms of metals caused by attractive force between positively charged metal ions and negatively charged free electrons. The atoms are packed closely together in giant lattice structures, bond forming. Each atom in metal gives up valence electrons to form positive ions. There are free electrons moving between these spaces, and positive metal ions are attracted to the sea of electrons which hold the atoms together. Structure and properties of metallic bonds. Number 1, metals can be bent, ductile, and can be stretched, malleable, because the layers of atoms in metals slide over each other when force is applied, but will not break due to attractive force between electrons and metal ions. Number 2, metals conduct electricity as it has free electrons which carries current. Number 3, metals conduct heat as it has free electrons which gains energy when heated and moves faster to collide with metal atoms, releasing heat in collisions. Number 4, metals have high melting and boiling points because the bonds between metals are very strong. Hence, very high heat energy needed to break the bonds. Please like, subscribe, and click the bell icon to get the latest updates and live stream notifications from the Saaz Academy. Thank you very much.